Plastics, plastics. Get your plastics here. Like me old China. Traditional plastics? Nah, you don't want them. They're from crude oil. What about this one? 30% renewable resources. That brilliant. But I know you lot. You want the nuts, mats. You want. Yo, what I got here is you've got 100% renewable and in the right conditions, biodegradable. Lovely jubbly. What am I talking about? I'm talking about renewable plastics. And these plastics are polymers. And your traditional plastics are long macromolecules, long polymer chains, with the monomers being the repeat units, and these are derived from crude oil. And crude oil is a non-renewable resource that at some point will run out, so we really need to be looking at what our alternatives can be. Well, one alternative is to look at getting monomers from a renewable resource such as biomass. One example would be to take cornstarch and ferment it, and you can get lactic acid. And this can be polymerized into polylactic acid, or PLA, or we can also call it polylactide. And that can be polymerized in much the same way as our traditional plastics into long polymer chains, and it can be used in similar applications. However, it does have some limitations. You can't put hot drinks into a PLA cup like this, for example. And so there needs to be research done into kind of expanding its applications by controlling this renewable polymer's properties. For lactide in particular, one possibility is that the lactide monomer can have different orientations, or in chemistry, stereochemistry. And then how these are joined together in the polymer chain can be different. It can either be alternating, like this, and that really wouldn't give us any benefit over the kind of PLA that we have here. However, if we start to arrange it into a block, I'm depolymerizing, like this, we call this a stereo block, we suddenly start to get some interesting properties in our renewable plastic. In fact, it increases the melt point, so we can start to look at engineering applications, and in fact, you can perhaps even put hot water in it as it remains crystalline above 100 degrees C. Another thing you can do with this renewable monomer lactide is mix it with other monomers, whether they be renewable or otherwise, and create copolymers. And again, when we make these copolymers, we want to be able to arrange them in a certain order to control the properties, whether this be degradation rate, if we're looking at biomedical applications for this biocompatible polymer, or if it be tensile strength or gas permeability, if we're looking for our plastic bottles and food packaging. And so how do we control how these monomers are built? Well, in my PhD, I design initiators that are selective in the polymerization of lactide with other monomers to create renewable polymers that could be used in a wider range of applications, both commodity and biomedical. So thank you very much.